Hello, ladies and gentlemen, and welcome to the next lesson in the small unit, or mini unit on hyperbolas. In this unit, in this lesson, we're going to be looking at going from the general form to the standard form for the equation of a hyperbola, very much like we did with circles and ellipses. Okay, there are a couple of little differences here. For instance, the coefficients of the x and the y. Um, They have different signs, but they can be the same number. So one will be positive, one will be negative. This example isn't a very good example. So I'm going to try and use this pen again and change the plus sign there to a minus. Okay. So if we look at that, the x squared term is positive, the y squared term is negative. Okay. It's the other way around. It could be the other way around as we've seen. So let's take a look at one of these. Okay. So I'll write the equation of the hyperbola in standard form. So the first thing we're going to do is group the terms like we've been doing, okay, and move that constant to the other side. So put the x and the x squared terms together, the y and y squared terms together, and get rid of that 55. Move it to the other side. So then what we're going to do is factor out just the coefficient of the x squared and then the y squared if there is one, okay? We're going to complete the square. So over here you need to add 9 inside the parentheses. So on the right side we're going to add 9 times 9. Over here you need to add 25 to complete the square. So it's negative 4 times 25 that we add on the right side because there's a negative 4 outside the parentheses because we factored the negative 4 out of the y squared and the 40y. So notice the sign change. We start out with negative 4y squared minus 40y. You factor out the negative 4, and you have y squared plus 10y. Okay. So the right side of the equation is 36. The left side, just like we were doing with the square and the ellipse, we force these two in the parentheses to be perfect square trinomials, and we know that they will factor to a binomial times itself. At this point, you can divide everything by 36 because the equation must be equal to 1, okay? So we can divide by 36. And then when you reduce the fraction, 9 over 36 is 1 over 4, then you can put in the binomial squares, okay? So we look at this hyperbola. Fractions, okay, equal to 1. And unlike an ellipse, there's a minus sign between the two terms, okay? So this is pretty much the process we were doing with circles and ellipses. So now when we look at this hyperbola, the center is at 3, negative 5. 4 is a squared, so a is 2. 9 is b squared, so b is 3. And your vertices are at 5, negative 5, and 1, negative 5. Okay. Let's take a look at another example. So at this point, why don't you pause the screencast and try this one on your own. The process is pretty much the same as what we were doing with ellipses and circles. So pause the screencast, try this one on your own, and after you've done that, come back to the screencast and we'll go over this. All right, so welcome back to the screencast. And so let's take a look at this. I'm practicing using the pen on my pen tablet here, so I'm not using the mouse this time. So if we take a look at this, 5y squared, 25y squared minus 9x squared minus 100y minus 72x minus 69 equals 0. So we're going to group the terms. Now, the y squared term is positive, the x squared term is negative. So you're going to put them in that order, not necessarily the x term first, because in a hyperbola, one of the terms will be negative. That goes second. Okay. So just remember to put them in the correct order, and then we move the 269 over. So at this point, we're going to factor out the coefficient of the y squared and the coefficient of the x squared. We need to complete the square. So over here on the left, we're adding 4 in the parentheses. So on the right side, we're adding 25 times 4. In the parentheses here, we're adding 16. So on the right side, we have to add negative 9 times 16. So we now have completed parentheses on the left. The right side of the equation is equal to 225. What I did here, which is different than the first example, before dividing by what's on the right side of the equal sign, I took these parentheses and made the binomial squares out of them. Okay. Now, let me scroll down. I'm getting used to the 10 a little bit better here. Now I'm going to divide everything by 225. So we wind up with y minus 2 squared over 9 minus x plus 4 squared over 25 equals 1. There's the equation of our hyperbola. And the center is at negative 4, 2. You have to remember, even though the x term is second, that's still the h part of the coordinate at the center. A squared is 9, so a is 3. B squared is 25, so b is 5. And here we have 2 vertices. So if you need to play this again, go over the screencast again, and I will try and figure out why this screen did this. There we go. So I'm still playing around with this pen, as you can see. Hopefully I'll get better at it as time goes on. So I'll see everybody in class. Thank you for tuning in to the latest episode of Math 12R Screencast Lesson.